So we're asked to find the circumference of the large circle if the circumference of the small circle is 2 pi. So I will solve this question in two parts. First, I will relate the big circle with the, as you can see, this is a rhombus. Are you seeing it? The sides are congruent and it's a quadrilateral, so it's a rhombus. It's not a square because one of the interior angles is 60. So it's a rhombus. So I have to relate the rhombus with the big one. That's the radius of this one, the big circle, with this side of the rhombus. After, we now relate the small circle with the side of the rhombus. So I have to do these two parts. So I will start with the big one. So they say find the radius of the circle in terms of the side of the rhombus if one of the interior angles is 60. So what I will do, I will say let the radius be r, that's radius of this circle, and the side of the rhombus be x. So that's it. So let's join. You know, if you want to draw a circle, this circle, we need the radius. So as you can see, from O to T is the radius. So let's join. We know that the radius is always perpendicular to this line tangent to the circle, so it's perpendicular to this side. So let's call the radius r. So our r is here. And remember, they said one of the interior angles is 60. I think the smaller one, this is 60. This is also 60. And since here is 60, here will be 120. That's consecutive angle theorem. In any parallelogram, if you add these two angles, always 180. So if here is 60, here is 120. Here is also 120. As opposite angles are congruent. And the diagonal bisect the vertex angle. So this diagonal bisect this. So since this is 60, this should be 30. And since this is 120, this is 60. So no need of using this. Let's focus on here. So from here, as you can see, this is 30 there, so this is 60. Angle sum theory for triangle is 30. That's to make it 180. So using our 30-60 triangle theorem, I've said, I don't know what I've said, this is simple, that if you have a triangle that the interior angles are 30, 60, and 90, once we know one of the side, you can get others fast. So assuming the side opposite 30 is x, the one opposite 60 will be x times root 3. And the one opposite 90 is 2 times x. So I will use it here first. So if we call here r, the one opposite 30, that's taking this triangle. If this is 30, so the one opposite 60 will be r root 3. Using this theorem, x here is r. And here, the one opposite 60 is r. The one opposite r 30 will now be r over root 3. So we've gotten the total length of this rhombus, and we say let it be x. So from here to here, you know, in a rhombus, all the sides are congruent. So therefore, r root 3 plus r over root 3 must give us x. So we are solving for r. They say we should find r in terms of x. So if I factor, okay, we can rationalize this as r root 3 over 3. What x? Yes, we can rationalize, multiply by the conjugate, which is root 3. The LCM of 1, 3, and 1. So which is 3? So which is from? That's 3 r root 3 plus r root 3 is equal to 3x. So I just multiply each by 3 to clear the fractions. So as you can see here, we can factor r. So we are left with 3 root 3 plus root 3. Why this is 3x. So solving for r, add this 3 root 3 plus root 3 is 4 root 3. So we now have 4 root 3 r equal to 3x. So solving for r is now 3x over 4 root 3. You can still rationalize, maybe multiplying by the, okay, let's just see. 3 is root 3 times root 3 over 4 root 3. So root 3, so we have root 3 over 4x. So that's our radius. So that's the radius of this circle in terms of the side of the rhombus. So we are given the diagram. We are asked find the length of the side of the rhombus if the perimeter of the circle, this small circle, is 2 pi. Okay, we know that for the circle, for the circumference of the circle, to be equal to 2 pi implies that the radius is 1. Yes, because circumference of a circle is 2 pi r. So the radius of this circle is 1. So that's it. So let's join some points. Let's join the diagonals. So we've joined the diagonal, and we know that the diagonals are always, from the property, the diagonals are perpendicular bisector. So this 90, they are all 90. So if we take, okay, let's call here O. Let's take DCO. This is an equilateral triangle, yes, because for this to be 60, this is also 60. We know the reason. Opposite angles of a parallelogram are congruent, and the diagonal bisects the vertex angle. Yes, the diagonals bisect the vertex angle. So this is 30. This is what? 30. So if I call the length of the rhombus x, so looking at this 30, this should be 60. So this is 60. Here is also 60. We have 4 congruent triangles. So from here, using our 30, 60, 90 triangles theorem, since here is x, this one opposite this will be x over 2. Yes. So let me just swipe this so that this x over 2. Since the one opposite the hypotenuse is x, so the one opposite 30 degrees, we'll call it 30, 60, 90 triangle theorem. Okay, maybe let me just explain down here that if you have a triangle, if here is 30, here is 60, and the one opposite 30 degrees is x, the one opposite 60 will be x times root 3, while the one opposite 90 will be 2x. So that's why, since here is opposite 90, which is x, the one opposite 30 degrees will be x over root x over 2 root 3. So this x over 2 root 3. So this from this point to this point is x over 2 root. Okay. And remember, the radius of this circle is 1. And here, if we call here this A, B, C, D, this point, if we call it E, we know that BE is the same as X. Yes. Because this is like the radius of this circle. If I complete a circle here, if I want to draw a circle, this is the center. So I'll complete it. This is the radius. So BE is also X. So see what I'm saying? I'm saying that EB is X. And we know that EB is from here to here, which is 1. That's the radius of this small circle, plus from here to here, which is our x over 2 root 3 is equal to x. Do you get the logic? I say since here is x, here is x root 3. So if you add 1 and x over 2 root 3, it will give us x. So our main aim is to solve for x. So let's solve for x. This goes, okay, let's multiply both by 2. So we'll have 2 plus x root 3 is equal to 2x. Yes. So we'll make x the subject of formula. So this, we'll move this to the other side. So we'll have 2x minus x root 3 is equal to 2. So we'll factor x. So we have 2 minus root 3 is equal to 2. Therefore, x is now equal to 2 over 2 minus root 3. So we'll rationalize by multiplying by the conjugate, so which is 2 times 2 plus root 3. Why this will turn to difference of 2 squared. 2 squared minus root 3 squared. So x is equal to 2 squared is 4 minus, so we are left with 2 plus root 3, which is 4 plus 2 root 3. So that's the value of x. And we're asked to find the length of the side, which is that. So that's our answer, 4 plus 2 root 3. Since we've seen that the radius, remember, the angle here is 6. So the radius, when one of the interior angle is 60, is equal to root 3 over 4x. And we've calculated that x is 4 plus 2 root 3. Remember, the radius we are talking about is the radius of the big circle. The big circle is root 3 over 4 times the side. That this side is x. And therefore, our job is almost done. Therefore, the radius, because we need to know radius before we talk about circumference. Radius is now root 3 over 4 times 4 plus 2 root 3. So let's finish up. These are equal to root 3 over 4. We can factor 2, and we have 2 plus root 3, which is 2. So I have root 3 over 2. 2 plus root 3. And okay, since we are talking about circumference, and we know circumference of a circle is 2 pi r. So I can just cross multiply. So I can get 2r is now root 3 times 2 plus, to make our work easier. So 2r is this, and we can open up root 3 times, that is 2 root 3, plus root 3 times, that is 3. Therefore, the circumference of this circle, of the big circle, is now 2 pi r, which is pi times 2r, and 2r is 2 root 3 plus 3. So we can rewrite it as is equal to 2 root 3 plus 3 times pi. So that's the answer. So I just partitioned the solution so that it will be easy for us to understand. Thank you.